Hello and welcome to the York Observatory YouTube TeleTube special event for the Great Conjunction of 2020. Our YouTube program is one of many of our online astronomy and astrophysics shows, this time on a Monday. These shows are always written and presented by students, faculty, alumni, and friends of York University. I am Professor Elaina Hyde, and I'll go ahead and get us kicked off tonight for our great event here. Welcome, everyone. As you can see, I am live at the Elaina Hyde Observatory, just waiting to see if the clouds will clear here. And I am joined tonight by a wonderful crew featuring our very own Professor Paul Delaney, Professor Jesse Rogerson, and our wonderful observatory crew members, Gagan and Noah. Now, as this is a special event, just a little note to get us started here, this show is taking place a little outside of our regular time slot. So our regular TeleTube broadcasts are on YouTube every Wednesday night at 7:30 p.m. local Toronto time. So if you'd like to catch any of those, or during the holiday season, reruns of previous episodes, you can always come back to our YouTube channel on Wednesday at 7:30 p.m. for those live chats. And that's the AICO Observatory Live, which of course you all probably know because you are here. So just as a little note, any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can also connect with us on Twitter or Instagram with the handle of @York Observatory and Facebook at Elaina Hyde Obs. Okay, this year we have started off with quite a bang. It has been a fabulous year, and we know it has come across all kinds of things, not just the Great Conjunction. We had the amazing occultation of Mars by the moon very, very early this year. And of course, Mars's closest approach since 2003. But tonight, on our winter solstice here in Canada, it is Jupiter and Saturn's turn to shine. So as a little getting started here, I thought it might be fun to do a little what's up tonight. So of course, we have Jupiter and Saturn, but if you're out, you might be doing a little stargazing as well. So if you are looking uppity and you can see in the south, sort of southwest direction, the setting sun, we also have a moon, which is going to be up and in a waxing gibbous phase, rising about just after noon, so probably visible for a good part of the day if you could see it. And it's going to be up until about 11 p.m. tonight. So you will be able to see that wonderful moon and the full moon arriving later on this month. So to get a little bit of a better view, I thought I might try to see how the sky might change tonight. So if you're doing a little stargazing out and about anyways, let me go ahead and put this on. So this is a small animation that I did earlier from Stellarium, which is a very fun site. So any amateur astronomers out there looking to do a bit of stargazing, I highly recommend Stellarium. So from about now until midnight, we're of course seeing the sun go down and Jupiter and Saturn are following it down that southwest horizon. If it is clear, we will be able to catch them before they disappear completely. And now as the sun goes down, the absolutely best time to catch them would be just as you have the minimum amount of light from the sun coming in, and of course they're still high enough to point the telescope at. So fingers and toes crossed for that. So in this image, you can also see it's not just Jupiter and Saturn. In this image, they're actually looking like they're one spot together in the sky. If you stay up later tonight, you will have, of course, that moon coming across, but also the planet Mars, and we'll have the Pleiades in the east, which are going to be visible almost all night and set in the early morning. And just as a reminder, the Pleiades are an open star cluster containing thousands of stars and also a lovely, lovely open nebula cloud. So they appear as a small collection of 6 to 7 stars. Most nights are 5 to 6 stars, as what most people can see. If you're lucky to have exceptionally dark skies, you'll be able to see more, especially if you also have a telescope. So you'll also have rising tonight the constellations Taurus and Orion following the Pleiades in the east. So keep an eye out for that red bullseye, Aldebaran and Orion's nebula. So what you see now is later on tonight. So if you are a bit of a night owl, you will be able to, of course, catch Orion. You'll also have the Andromeda Galaxy up in the sky, another object high in the sky this evening, setting a few hours after midnight, but you'll most likely need a telescope or binoculars with a very dark skies to see it. It is a large and dim object. So we have the Pleiades, Mars, Jupiter, and Saturn, as well as other stars and the moon we can see as our naked eye. And if you want to get a little more detail on some of these, a small pair of binoculars or telescope is a great aid. So we always recommend those. And this special event, of course, is going for Saturn and Jupiter, which today, as of today, are appearing to us as the closest together they've been since about 1623. Or if you go for the best view that all of humanity has had, this is the best view for them being close together that we've had since about 1200. And you're going to find out a lot more about that during this broadcast. So since they have a minimum separation of just 0.1 degrees, they will be viewable together through the eyepiece of telescopes, which is going to get us some fabulous, fabulous views. Of course, there is one other significant event happening today, as you might have heard from other places. It is, in fact, the shortest day of the year here in the Northern Hemisphere, and that's the winter solstice. So we have the winter solstice today, our shortest day, our longest night, and of course, the Great Conjunction, which is, just a lot of fun. So I thought I would go ahead and put a little spoiler up of what we can see through the eyepiece of the 1 meter telescope. What we have seen in the past, like I said, at this second, it's just a bit too cloudy. If it clears, the telescope will open and the views will come through, and you'll be able to see Jupiter and Saturn. So this is a little bit of a zoomed in view, and a little bit of I suppose, a recap of previous TeleTubes where we have been able to do live imaging. So I've also put the Pleiades in just as a little extra source of inspiration for late night stargazing. And, all of these are through relatively clear nights through our 1 meter eyepiece cam. Now I say eyepiece cam because this is a little bit different than processed images. So you're going to see 2 kinds of main images today, and one is eyepiece camera images, which is what you would see with your naked eye through the eyepiece of the telescope, and the other is images that go to a CCD and are actually processed with a computer. And those ones always look sharper and a little bit more impressive because you can gather a lot more light and more accurately create the image. So this is our eyepiece. These ones in particular actually came from our regular night OPV and our Wednesday night TeleTubes. So if you want to see more of those, you can actually catch them in the recordings of our previous episodes. So you can find more information about all of these events on our website, observatory.info.yorku.ca. Now we have a whole bunch of fun stuff we can talk about here. So I'm just going to really quickly do a short recap on the winter solstice, actually, because I know that it's been talked about before, but we have a whole host of very qualified people in our show tonight. Now, Professor Rogerson, I believe you also had a few words about the winter solstice.
The winter solstice. The winter solstice is such a, thanks for pulling me in. I love talking about this kind of stuff. Yeah, the winter solstice is if you're in the north, this is your shortest time of year, December 21st. If you're in the south, this is your longest time of year. So it'd be your summer solstice.
Yeah.
Very good.
I think it's really interesting from a historical perspective. Every culture you look around the world, and you find different celebrations and rituals and just ways of honoring what was observed to be happening, and that is that the sun was getting to its lowest point on the sky. It was somewhat standing still, and then this was the moment that the days were going to get longer. When you think about it, and you think that we still celebrate it, that right there is just a perfect demonstration of how deeply connected humanity is to nature. We tend to think of ourselves as separate from nature, but a ton of our cultural practices are based around natural events, and the winter solstice is just an example of it.
Exactly, and as we go around, this is of course due to the tilt of Earth's axis, and this is a short image showing Earth going around throughout 1 year, and this is why our winter solstice is the southern hemisphere's summer solstice. It is the tilt of the axis, either pointing more towards or away from the sun. So you can see it's marked towards summer here on the right-hand side of the diagram, and the top part of the planet has more light when it hits that summer part, which is our northern hemisphere. Now, just as an extra little one, this actually is thought to be caused all the way back in early Earth's formation, when you had an object that is, again, presumed to have been roughly the size of Mars, crashing into the newly formed planet Earth about 4.5 billion years ago, and knocked our planet just a little bit and left it tilted at this angle of 23.4 degrees approximately. And this tilt is what gives us our seasons, and of course our solstices and our equinoxes. So the winter solstice this year, thanks to that protoplanet, not Mars, for knocking into us and giving us these interesting seasons. Now, there are a bunch of different things that we can discuss about this event, but I think before we go too much further, we ought to let Professor Delaney tell us a little bit about what a conjunction is exactly. So let me go ahead and find that, and let's see, here we go. Professor Delaney, take it away.
Thanks, Elaina, and hi, Jesse. Yeah, it's a wonderful time of the year. There's no doubt in the world about that. I mean, putting aside the grand conjunction that we're going to be talking about tonight, winter skies are fabulous, as Elaina has indicated, all the way from, the wonderful constellations of Andromeda and Auriga, Orion. There are terrific things in the night sky. And so, staying up all night, and it's a long night, of course, here in the Northern Hemisphere, well over 12 hours worth of darkness. It's just a terrific time of the year. Anyway, I digress. Conjunctions. So we're into this mindset of what changes in the night sky. Wanderers, that's the definition of a planet. These objects move with respect to the background stars. So, we've known this for thousands and thousands of years, being able to watch carefully the movement of these planets as they go across the sky. And not surprisingly, given the fact that these planets are in pretty well the same orbital plane as the Earth, they come into these periodic alignments. Now, as you go inwards from the Earth towards the sun, you get yourself to Mercury and Venus. And those planets, because they are moving very, very quickly around the sun, they come into alignments from our perspective here on Earth on a really, really regular basis. Other planets, because they are further from the sun, moving more slowly, they take a little longer to get themselves into alignments. As you can see on the schematic here, the animated schematic, because these three objects, Venus, I guess it is, Mars and the Earth, we are moving around the sun, differing orbital speeds, as I said, closer in, faster, further out, a little bit slower. There will come times when the objects are in these sort of gentle alignments. They're not really close to each other, but from our perspective here on the Earth, they do look as if they're in alignment. And so here you're looking from Earth inwards towards the sun, and you can see Venus is in front of us, and that is referred to as inferior conjunction. It also has another name, and I'll mention that in just a moment. When you're on the other side of the sun, then you're at what we refer to as superior conjunction. These are terms, they're astronomical terms. Astronomers love terms. There are other terms like opposition and so on. We'll talk more about them in just a moment. But the takeaway message at the moment is conjunctions are alignments from our perspective here on the Earth of the other planets, the other wandering objects in our solar system. And of course, there are 8 planets altogether, Mercury and Venus, inwards from Earth towards the sun, and then Mars, Jupiter, Saturn, Uranus, and Neptune. The last 2, of course, being telescopically discovered in the 17th and 18th century. Well, I guess it was the 18th and 19th centuries. So planets can get together in these alignments, and we refer to them as conjunctions. When Jupiter and Saturn do this, we refer to it as a grand conjunction or the great conjunction, because they are the biggest 2 planets in our solar system. But as I said, the takeaway message is conjunctions represent alignments of planets, at least 2, potentially more, from our perspective, but no chance of collision. We're talking about separation still of hundreds of millions of kilometers, but from our point of view, looking out from Earth, past one of the planets in the night sky, onto another one, because they're all orbiting pretty well in the same orbital plane as the Earth's orbit around the sun. Okay, so we've got conjunctions now sorted. As I said, astronomers have this tendency of wanting to clarify, classify, use nomenclature to be very, very specific about what's happening and when. And so I just want to run through a couple of other terms that you may well have heard about in, well, not comparison, but in the same breath as conjunctions. In particular, if you think about the word occultation. The occultation is when a foreground object slides in front of a background object. So normally this is, for example, say an asteroid or a minor planet in our solar system orbiting around the sun. Remember, the sun is the gravitational choreographer. It's the grand master of moving things around in our solar system. Well, these little minor planets, which can be anywhere from a few tens of kilometers in diameter up to nearly 1,000 kilometers in diameter, so not dwarf planets, but these smaller objects are often sliding in front of the background stars, the stars that are much further away. Well, when these minor planets, these asteroids, block out the light of a distant star, we refer to that as an occultation. Really, really important, as we'll talk about in just a moment, for figuring out things like the sizes of those minor planets, the shapes of those minor planets. So that's the term occultation. Similarly, if we use the term transit with respect to a planet, that is similar to an occultation, but this time the object, normally a planet, that is sliding in between us, the Earth. Remember, we're always doing the observing from the Earth. You're looking past the planet and is now silhouetted against the sun. So Mercury and Venus do this transiting bit on a, well, somewhat regular basis. I mean, Venus actually only slides in front of the sun twice a century. Okay, it's very close to the Earth's orbital plane, but it's not quite. And so while it slides into inferior conjunction, we mentioned that just before, where Earth, Venus, Sun are more or less in an alignment, they're not quite in the same plane. Venus can be above or below a line that goes from Earth to the sun. And so that means that an inferior conjunction is not necessarily a transit. But a couple of times a century, Venus does slide across the face of our sun from our perspective here on Earth. Mercury does it a little bit more frequently. It does it sort of once every 10 to 15 years. Again, it's not quite in the same plane as the Earth's orbit around the sun. So you've now got occultations, you've got transits, and now, just to finish this all off, an eclipse. And that's perhaps what we're most familiar with. The image that you can see on this slide, in fact, was an image of a solar eclipse that I actually observed all the way back in 1976. So here you've got the moon in its orbit around the Earth, sliding across and fully covering the disk of the sun. Now, the apparent sizes of these two objects are coincidentally almost identical. They're not quite the same, but they're very, very close. Physically, of course, the moon is much smaller than the sun, but the moon is much closer to us. And so its apparent size is almost identical to the apparent size of the sun. And there you can see the moon, that's the black disk, completely blocking the bright solar surface, leaving us this beautiful corona, the outer atmosphere of the sun. So an eclipse is also like an occultation. Okay, it's a near foreground object sliding in front of a background object, but now we're talking about shadows being measurable, shadows being cast from the moon towards the Earth's surface. So occultations, transit, eclipses, all very, very similar, dealing with one object becoming coincident from our perspective with another. And so you can see that when we start talking about the great conjunction, the grand conjunction of Jupiter and Saturn coming very close together in our skies from our point of view, that term, the grand conjunction, got similarities to occultations, transits, and eclipses. So all of these are differing astronomical terms talking to you about the majesty of the night sky, how gravitational forces are moving objects around and bringing them into wonderful alignments for our viewing pleasure here on Earth.
Excellent, Paul. And we actually have a little, I don't know, semi-question from chat live coming in.
Sure.
Robert is mentioning that there was a special observatory built by King George III to observe the 1769 transit of Venus. I hadn't heard of that one. Have you?
Yes, I did, actually. I can't tell you a whole lot about it, but transits of Venus over the last 400 years have been eagerly observed because they gave us insights into the scale of our solar system, to the atmosphere around Venus, and so on. And so when these two, they come in pairs, when the two transits of Venus in the 18th century were being planned for, because of course we could predict when these were going to happen. Well, we sort of moved heaven and earth to make sure we had good observing capabilities. And so there were some specialized observatories that were built and of course stayed on after the transit. And of course, we launched off expeditions around the globe. 1769, James Cook was heading towards Tahiti to actually make the observations of that transit, and then went on to run into the east coast of Australia. So yes, I am aware that there was a specialized observatory built to monitor that, but beyond that, I actually can't tell you very much about it.
Well, I think we have time for one more quick question before we go on to your next area of occultations. But there was a question from Ashi about what the difference is between occultation and eclipse, if they both pass in front of each other, which I thought was actually a good one.
Oh, it's a really good one. There's no question. That's why I was sort of mentioning all this, because these terms can be used quite interchangeably. An occultation, normally, that term is normally reserved for a smaller foreground object passing in front of a much more distant object. So a minor planet in our solar system covering over a very distant star that might be hundreds or potentially thousands of light years away. So really, really tiny points of light, one being obscured by the other. By contrast, an eclipse is a more local phenomena. So, for example, the moon, our moon, passing in front of the sun. The moons of Jupiter, you mentioned the moons of Jupiter, the Galilean satellites, Elaina, passing in front of passing behind Jupiter. So Jupiter is eclipsing these satellites. So they really are very similar terms, both talking about a foreground object moving in front of a background object, but eclipses do tend to be associated with objects in our solar system. However, having said that, of course, we are talking about the transit technique for exoplanetary discovery, and we often talk about the eclipses of those planets by their parent stars. So yeah, it really does get confusing. Occultations and eclipses, very, very similar, involving foreground and background objects.
Wonderful. So we go on to a little bit more about the occultations?
Well, absolutely. I mean, yeah, I know the main aim tonight is about the grand conjunction, but just to show you how amateur and professional astronomers can do terrific science together, during the mission New Horizon out to explore Pluto, after that mission was completed, they redirected the spacecraft onto another object. At that time, they were calling it Ultima Thule out in the outer solar system. It's what we refer to as a trans-Neptunian object. It's a small object, only a few kilometers in diameter, and it's orbiting well beyond the orbit of Neptune and Pluto. They're now calling it AICO, if memory serves. But back then, in sort of like 2015, 2016, we really didn't know very much about this object, barely anything about its size. We knew, though, that it was going to occult a star in 2017. And so astronomers, amateurs and professional across the planet, got together to observe the occultation of a particular star by this object that we refer to as Ultima Thule, this trans-Neptunian object. It's basically just an asteroid. By stretching our baseline across the Earth north to south, in other words, we had astronomers in South America, we had astronomers in North America, we had astronomers in Africa, we had astronomers in Europe, all observing the occultation, this object running across, if you will, blocking the background star. You can see the differing lines of observation on the left-hand side that were made during this event. And depending upon the very small changes in angle by virtue of latitude that observers were looking at Ultima Thule, we were taking sort of like cross-sectional cuts through this minor planet. And we were able to actually figure out the rough shape and the rough size, like really actually surprisingly accurate. The image on the left is the sort of the composite image of several observers at differing latitudes, and the image on the right was actually taken by New Horizons as it slipped past Ultima Thule, AICO, on January 1st, 2019. The image on the left, if you look at it sort of, it's slightly tilted, but it's really, really close to what actually New Horizons was able to image. So the power of occultations, to me, has never been better represented than by looking at this observation of Ultima Thule. Amateur and professional astronomers strung out across the planet, looking towards a minor planet as it caused the background star to disappear, an occultation. There you go. Over to the next aspect of tonight's observations, Elaina.
All right, thanks for that wonderful explanation from Professor Paul Delaney. And we'll go ahead and start talking a little bit more about conjunctions here. So this event in particular, and I'd just like to give a little bit of credit to one of our other co-hosts, Professor Jesse Rogerson, who actually took the image that I'm showing here.
Actually, my partner took that image.
Oh, let's get the image credit correct then. Thank you. And yes, Jupiter and Saturn passing within 1/10 of a degree. So this is from a few days ago. And this is the closest that they have been since 1623. However, as has been noted before, the 1623 conjunction was not especially easy to see because at that time they were quite close to the sun. So you wouldn't have been able to see it, for example, from Toronto or the general Ontario region or anywhere in Canada, really, basically equatorial. So this conjunction is an absolutely fabulous opportunity. And just as a little side note, we call it a great conjunction, as Professor Delaney said, because to ancient sky watchers and throughout human history, these two wanderers were two of the slowest that you could easily see with your naked eye. Jupiter takes about 12 years to go around a full circle throughout the heavens, so about 12 years for it to make that orbit around the sun. spending about a year in each zodiacal sign in the sky. And then Saturn takes even longer, 29.5 years, to make one full trip around the sun. So they're very slow, sluggish wanderers. They drag their feet a little bit. And if you were watching this in ancient times, you would have to watch for 12 or 29.5 years to see a full circle. So if you saw 3 orbits of Saturn, you're almost 90 years old, and this is a significant a way of keeping time. So this kind of great conjunction happening, it is a significant event. It's 2 of our slow, sluggish wanderers managing to pass each other in the sky. And this is a celestial summit meeting, if you will, or a conference call. No, I don't know. Pick your favorite geeky meeting forum, and this is what the planets were doing. Celestial Zoom call. It is very unusual, and it only really happens that they come across each other in the orbits about every 20 years, but they're not always this close. They're very, very rarely this close. And then the one that's going to happen in 20 years from now, they're going to be quite a bit farther away. So these get-togethers are, great conjunctions when it is Jupiter and Saturn. So this period of, conjunctions, and we're going to talk a little bit more about the history of these later, but in the last 1,000 years or so, there's really only 6 great conjunctions where the separation has been less than 0.2 degrees. So it is an interesting effect that once it gets within that 0.2, 0.1 degrees, it really starts to look like one object in the sky, and that doesn't happen terribly often. Now, one of the things with this event, please keep in mind, these planets are not physically close to each other. Compared to any measurement that we know of here on Earth, they are still very far apart. Jupiter is what we call about 5.2 or so AU from the sun, and that's 5 times farther than Earth to the sun. And Saturn is almost twice as far away as that. So the distance is immense. So Saturn is 9 AU, and this is millions of kilometers. So Saturn and Jupiter are actually 733 million kilometers apart. So there's no chance of them running into each other. There's no chance of them doing anything to each other or any of each other's moons. So Jupiter has moons, as you'll find out about more later, and Saturn's rings. They're so immensely far apart, they cannot actually do anything, but it appears that they're close in the sky. And that's one of the interesting things about this event. So this separation, of course, being bright objects, it means that they are very nice to see with the naked eye. So of course you get lovely astrophotography of all kinds, like the one you see here, as well as some abilities to actually go out and measure it. So I'm going to show you a little video that is very, very unphysical, but it's just meant to demonstrate the size of the separation of these 2 objects. So because this is a bright object and it's easily visible from many areas on Earth, this is very unusual. Like I said, not taking into account the glare from the sun that is compromising a few locations still. So let me go ahead and show you what this, how close these really are. So this is an animation done by James O'Donoghue using NASA data. And we're going to do something you should never, ever, ever try, which is to put Saturn and Jupiter in front of the moon. So don't try this at home, kids, or just don't try this at home at all.
What? Why not?
Jupiter and Saturn running in front of the moon, while they would fit between the distance from the Earth to the moon, would be a very bad idea gravitationally.
Can you imagine the tides? That'd be amazing.
It would be
disastrous.
Yeah, briefly amazing.
It would be absolutely incredible. So because 0.1 degrees is hard to picture, I'm showing you here what they look like in front of the moon, because the full moon is about ½ a degree in diameter. And we've talked before about, holding your pinky up to block out these stars in the sky, and why can you do that? Well, if you hold your pinky out at arm's length, straight out, and the tip of your pinky is about a degree, so you'll be able to block the moon. Now, if the moon is ½ a degree, 0.1 of that, and I'll just click this again, means that as Saturn comes by, and you can see it here, this would be the path of Saturn. Jupiter, which is orbiting inside of Saturn, moves faster, catches up to Saturn, and then comes within 0.1 degree, and that would be about that fraction of the moon, so about a fifth, well, a little less than that. So you can see how small that would be compared to the full moon. And this has the dates on it as well. So you can kind of see that as the date runs forward to today, this is when we get that closest approach. And so they'll still be pretty close tomorrow, but not as close as they were today. And they're going to get farther and farther apart because Jupiter is moving faster than Saturn. If we had to rely just on Saturn, it would be a very, very long time because Saturn takes so much longer to go around in its orbit. So just a couple little, fun facts about this particular event. Now, one of the other things is if you are out looking for it and you do have clear skies, which we don't quite, let's see here. So this is a little bit of an image put together as what you would see naked eye from a big city. So this is quite nearby in New York. So Toronto will see a very similar sight. Basically in Ontario, you'll be able to see about the same. And Saturn and Jupiter moving through the sky on various different days. As you get closer and closer to December 21st, we kind of go down through this line, and you get December 21st, them looking at as one object in the sky, lower and closer to the sun. So that in together will help us to kind of picture what to look for if you're running out and having a peek right now. So if you are out, look south, southwest, and don't look directly at the sun, no matter what. Definitely don't look directly at the sun, but just above from that, you should see a very bright star following it down. Okay, so what is so unusual about this particular great conjunction? And this is another image credit to James O'Donoghue, who put together some wonderful animations showing just how these would move. It's the closeness of Jupiter and Saturn are really, really spectacular on this particular event. So this is a little animation showing them kind of without the moon interfering in the background here. And as they approach December 21st, our wonderful winter solstice, they get closer and closer and closer to each other in the sky. So the closeness on the solstice is a really wonderful holiday event. Viewable at most locations on Earth means that even though it's still just a bit too cloudy outside, what we can do is hop over and have a look at some telescopes from other locations on Earth. So we can still show you some live images. And I'll just go ahead and hop up to one of our live images now. Let's see here. Where on Earth shall we start?
The live images, that's what the people came for, right?
Yes, exactly. So because we have this event happening everywhere all around the world, this means that, at different points, depending on where you are on Earth, your particular view of Jupiter and Saturn will be closest in the sky at different times. So this is great. So if you're in LA, it was 9:43 a.m. on the 21st. In New York, it was noon. Rio de Janeiro, 2 p.m. London, 5. Paris, 6. Istanbul, later tonight. Dubai is even later, New Delhi even later, and Tokyo is tomorrow, so the 22nd. And this is where it gets hard actually, because Sydney, you have to cross the date line. So the 22nd isn't the 22nd. It's already the 22nd in Australia. So don't get fooled.
That's why Paul always knows the future.
What can I say? Yeah.
Exactly. So don't get fooled by the international dateline. But where in the world you can view this will depend on, what time it is as well. So you have this whole, I want to say a conjunction of interesting events, but I'm not sure if that would be.
You got conjunction on the brain.
I do. For some reason. So let's go ahead, and because it's happened so many different places on Earth, earlier today in India, the Indian Institute of Astrophysics did a wonderful live view. So we're going to go ahead and get into the live view here, and let me just go ahead and make sure that I start this correctly.
And when we say live view, we're meaning live view from a little while ago.
Correct. Yes.
But a good way to look at this, though, is that yes, it's live from a little while ago, but it's basically what you would see if we were able to point our telescopes at it. This is a similar feeling that we would get right now.
Quite correct. Quite correct.
Indeed. So let me go ahead and start this again.
So I'm definitely sad that we have clouds over top of the Alan I. Carswell Observatory right now. But this is the wonderful thing about how interconnected we are all now. Because if you imagine what this would have been like, say, I don't know, even like 20 or 30 years ago, if you were in an area with clouds, you were out of luck. But nowadays, we can literally look through the eyepiece of a whole bunch of telescopes all over the world through YouTube. Like, how great is that?
Certainly is. It's the marvels of modern technology. And here you've got the two planets of our solar system clearly showing the rings of Saturn on the left, clearly showing the Galilean satellites orbiting around Jupiter in the same field of view. So this is, to me, just magic.
Yeah, this is the key to what you're looking at here, everybody, is like that is an actual image. This is actual stuff. It's not an animation. That is the actual image of those two planets right beside each other. Jupiter is 5 times the distance of Earth to the sun, and Saturn is 2 times that distance. So Saturn is 2 times further away than Jupiter is in this image, but they're right next to each other because of the way the orbits, as Elaina and Paul have already described. Like, it's really incredible to get them both in such a tight field of view.
Indeed, and it just goes to show, this is why we love collaboration in science.
It's the way it should be, right? Everybody shares data.
The other thing to remember, of course, is that even though we've been, as a planet, as a civilization, watching these two objects move across our sky for thousands of years, it wasn't until Galileo and company turned telescopes onto them that we actually realized that they were real worlds. They were 3-dimensional objects. They were objects, well, I'll say somewhat similar to the Earth. I know there are many, many differences, but these are planets, not just points of light. And that is relatively new. Less than 400 years ago, we made that realization.
Yeah, I love that. I tend to think about this whenever I teach about Galileo. He made a couple of really interesting discoveries that I think people don't realize. Like, everybody realizes, yes, he discovered the moons of Jupiter. We call them the Galilean moons, but he literally discovered a new thing in the solar system. Nobody knew that moons existed in the solar system other than ours, right? But we didn't really have, at the time of Galileo, there still wasn't a solid consensus that it was heliocentric solar system. So the fact that they were even worlds on their own, he discovered both moons, the idea of a moon around another thing, and he also discovered the idea of a world out there. Like that didn't really exist the same way until he was able to get a telescope pointed at it. And he had contemporaries also pointing telescopes at things as well, pointing at different objects in the sky.
Yeah, the higher resolution and images he was able to get on the Galilean moons was indeed a first. I believe the very first observations of the moons existing actually came from China, who did a sort of a naked eye observation, if you will.
Oh my gosh, I didn't know that. They did a naked eye observation of the moons?
Of the moons of Jupiter, yeah, exactly.
Oh my
But
gosh.
it was obviously much lower resolution. So as with all live streams, they did have a few issues with their telescope coming through.
So this, just looking at this, it's blowing my mind. Like, I know we've already talked about what's on the screen there, but like, that's incredible to be able to see these two gas giant planets so close together.
Absolutely, yes. And of course, you can clearly see Saturn in the top right is elongated. I mean, it's a slightly overexposed image so that we can see the Galilean satellites around Jupiter, and you can't see the detail on the surface of the cloud top surface of Jupiter, but you can clearly see that Saturn is elongated. And so you can have Saturn merging with the elongated ring system there. When Galileo first observed it, he is reported to have said he has found an object with ears, a planet with ears, because his resolution wasn't particularly high. He just saw it as elongated, and clearly, and clearly it was something that he wasn't expecting.
Indeed, and this is another fun thing, of course, with these live views, putting Jupiter and Saturn in the same image. You do sometimes turn the contrast up a bit so that the planets are a little overexposed, and that will allow you to see things like some of the moons around Jupiter, which of course they try to do here in this live stream as well, putting in the locations of Ganymede and Europa here. Fabulous moons of Jupiter, and it's a really wonderful job that they've done here with their live stream. So this is a great result coming out of Bengaluru, India, and a great result from the Indian Institute of Astrophysics live streaming the Great Conjunction. So
I don't know about all of you, but I really wish that I was I had my eye to an eyepiece right now. Yeah. That's for sure.
You're going to have to wait 400 years. I mean, that's the sad part about it.
400 years. Isn't there a Great Conjunction in 2080 that's really close together?
Relatively close together. That is true. Not as close as this one. I guess I was meaning in the order of a tenth of a degree, and that's not for 397 years. But you're right. The one in 2080 is not bad. I might miss that one too, unfortunately. But
I'll take what I can get.
Precisely.
Well, we're all very happy to be here for this one for sure.
Yes.
So speaking of course, moons and live views, we might go ahead and transfer a little bit from live views of live views out of India over back to a little bit more about this event and how it is exactly working. So we do also want to just show you really quick what is expected to be able to be seen. So you saw some of those moons and their positions being marked earlier on the live stream video. Now, this is basically how Jupiter and Saturn will look if you had, the perfect telescope with no atmosphere. So we're in space or we're on the moon and we have a really nice telescope set up and we can see Jupiter and its moons Ganymede, Europa, Io, and Callisto. And of course, Saturn. And if you had a really good telescope, you'd also be able to see Saturn's moon Titan, which is, of course, a fan favorite. So you might hear more about that one a little bit later, so no spoilers. But
best moon in the solar system.
Best, arguably the best moon in the solar system.
I'll argue it. Okay, keep going. Sorry, I'll stop interrupting.
We'll have a moon competition.
Yeah.
Anyone in chat who would like to argue that Titan is the best moon in the solar system, please have a go. All right, so obviously from the naked eye, it really does look like one star. one object, I should say, not a star. And through the telescope, if you were watching, you might be able to catch some of the moons, but you'll notice in a lot of the live views, the moons are really, really hard to see because if you turn the contrast just right for the planets, the moons will be too faint. And so a lot of times you'll see them trying to go back and forth between contrast. So you might be able to see that. And this scale on this image here, 1 arc minute. So this is very, very close together in the sky. So I'm hoping that somebody with very good camera is taking some great images right now and having a wonderful time. So we've kind of had a look about what's so unusual with this event, and of course the moons that might be visible. Now I just wanted to take a second as well and show you why this is happening with a little extra graphic from our solar system. So this is why are we actually able to see this? And of course we live in a solar system that is in a plane, as Professor Delaney mentioned before, and in this plane everything is orbiting around the sun in their not quite circular orbits. Okay, so we've got everything going around the sun, and because the inside planets are orbiting faster than the outside one, thanks to Kepler for pointing that out quite elegantly, and we have this relationship that we can use, and we can see that Jupiter will go around faster than Saturn, so it has a chance to catch Saturn every so often, and that so often is about 20 years. So you can see I've got a little green line here showing this is on today at 4:30, so about 20 minutes ago. So it hasn't moved much in the last 20 minutes.
Are you sure it hasn't moved much?
As our sun is setting, we're on a planet that is turning. The sun is setting, and we're looking backwards towards Jupiter and Saturn in a line. And so this is why Jupiter and Saturn are so close to the sun when they line up. And it's not an accident. It all happens on purpose, as it turns out. And we have Jupiter and Saturn. So if you imagine that you're somewhere down on this little tiny blue dot, and a little tiny, really minuscule sized human looking backwards out at Jupiter and Saturn, you would see them across the sun. And now you might see this diagram and say, wait a minute, if I was on the dark side of Earth and it would be night for me, I would actually be facing the other way. And this is a common problem, of course, with conjunctions and all kinds of things. How are we seeing it? Obviously, we're seeing it as the sun is setting. So we're actually kind of looking back along the edge of Earth, which is a really fun phenomenon. And this also happens a lot with, of course, conjunctions of Venus and Mercury. So I thought, because this is what we're all able to see, or all of us with clear skies and everybody looking through robotic telescopes, how does that actually work? How do we look over our shoulder, as it were? So how do we go ahead and look over our shoulder and see the sun, setting, and then see the planets at that angle as we do? So given the fact that we have day and night, we're going into night, but we can still see that other direction due to Earth's wonderful shape. So we have a wonderful round Earth, and this is the same reason why we can see Venus even as the sun is setting or rising. So one of the reasons why Venus is such a great morning, evening star is that we can look back across our planet, and we can see this diagram here is actually showing it how you would look if it was Venus. Your sunlight is coming in, and you've got some sort of a tangent out to that orbit of, for example, Venus, and Venus can be visible still while you're at this sort of edge of the curve here. And you've got a black area where Venus can never be visible. So after a certain time, you lose your chance to take advantage of this curvature. But we do have a shot, which is why, of course, we can see this alignment now and why it's so good. So one of the things that I always like to point out with this as well is, we're here on Earth, and we've talked about, moons of Saturn and moons of Jupiter. But what about our moon? And of course, there's some news from Canada that was just too good not to mention in an astronomy podcast.
Go for it.
So, as you may have heard, and I believe Professor Rogerson here has heard and helped to be heard, Canada is sending an astronaut around the moon in 2023. So one question is, if they were already there, and this is a little thought question for folks in chat, if they were already there, would they be able to see this conjunction if you were on the moon? So this is a fun thought question. So I'm going to go ahead and leave it open to chat.
So the problem here is that I actually don't know what the phase of the moon is right now, and I
didn't say where on the moon you had to be.
Ah, okay, good point. Okay.
So you can pick any location on the moon, and then tell me your answer from that location.
Okay. I don't want to get too into it. Let's let the YouTube chat box do some thought processing on that.
Excellent. So let's just tell everyone real quick about the event in case you hadn't heard. So in case you're wondering why we're all very, very excited, Canada is going to send an astronaut around the moon and deal with the US. This is a 2023 mission, which is part of what's called a Lunar Gateway project. It's a really cool idea. I can never resist telling people about it whenever I get the chance, but this project called Lunar Gateway is going to build a space station over the moon. So a literal space station in orbit around the moon. It is just super cool. It's really, really exciting. And of course, this planned trip in 2023, this will send an astronaut around the moon with this US-led effort, and it's a Canadian astronaut is going around. We'll get to see the moon, and hopefully also bring forth the ability for future missions that might land on the moon, more with the actual Gateway space station, and of course possible missions to Mars in the future, which always have to be mentioned. So the Gateway actually calls for a Canadian astronaut to this future space station as well. So the Lunar Gateway will have a lot of, so we're here in Canada, the Lunar Gateway is going to have a lot of Canadian events going on, of course, as well as Canada Arm 3. So if you haven't heard of this, is the part of the trilogy. Canada Arm, the grand finale trilogy. It will be on the Lunar Space Station. So our space station right now in orbit has a Canada Arm. Canada Arm 3 will be going to Lunar Gateway. And it will start off small, so about 1/6 of the size of the International Space Station. And 2023 will be not just this launch around the moon, but also the launch of two of the most important modules, the power and propulsion element and the habitation and logistics outpost.
Nailed it.
Yes, so those are both going to be launched in the same launch, and everyone's going to be biting their fingernails to see how it goes. This will be the first Canadian astronaut to go around the moon. And there are 4 Canadian astronauts currently in the Canadian Astronaut Corps, so everyone is kind of wishing them all good luck and also very, very curious. And just as this will make Canada only the second country after the US to actually have an astronaut in deep space. It is very, very exciting. So Jesse, you want to say a few words on this one as well?
Oh my gosh. I mean, there's so much to be said. I mean, I've read books, I've watched movies about the Apollo program. Like if you're thinking about like the impact that moon exploration by humans has done to our culture, to everywhere, internationally. We all know Apollo 11. We all know they walked on the moon. There's countless stories that have been written about it, and like the Armstrong movie came out just a couple of years ago, and there's books and there's artwork and there's all of that, but with one small downside, it was only from the United States point of view. And we get to enjoy it as an international culture. But what this step means is, and I'm so glad it's Canada, is that now it's going to be more countries. And I really hope it doesn't stop after Canada. I want more countries to get the opportunity to really join in with deep space exploration. So Canada gets this first step to jump off towards the moon. And then there's going to be groups from the ESA, from JAXA, from Roscosmos. China's going to be doing their own space exploration with humans in the next 5, 10, 15 years or so. And what that means to me is that we're starting to really think about this in international terms. I mean, well, we already were with the International Space Station, but deep space, it's not about one country, it's about all of us. And I'm really excited about that. Of course, I'm excited that it's Canada that's doing it first overall, like the ESA or JAXA or anything like that. But it's pointing to the right future. And that's what I really like about it.
Just one thought with respect to the reference back to Apollo. You're quite right, Jesse, that the Apollo mission, the space race, what landed us on the moon, what landed the United States on the moon, was very much from a US perspective. But the world really was watching. And I say this from experience, obviously. The entire year of 1969, with Apollo 9 and Apollo 10 and then Apollo 11, it was in the news constantly. I was living in Australia, obviously, at that point in time. I was going to school, but it was saturating the news coverage. And we didn't have internet back then. We're talking about radio, news, print, as well as television. Almost weekly, there was something about the moon landing coming up. And then when Apollo 11 actually launched on July 16th of 1969, you could not get past, the first you had to get past the first 2 or 3 pages before you found any other news. It really was riveting for the planet as a whole. And when Armstrong set foot upon the moon, he did it hours ahead of the original schedule. We were all watching. So yes, it was very much US centric, but rest assured, the world was watching.
Indeed.
I have no doubt that sorry, Elaina, I was just messing with my mic. I have no doubt, Paul. Yeah, I don't want to underscore the unity that did happen, or I don't want to undermine, the unity that did happen as a result of the United States doing it. I'm just excited to see another country going.
Agreed.
And like, how great is it going to, like, the images, like this is going to be in 4K, right? Like this is going to be high resolution. We're going to be able to stream it live on YouTube. Like it's a whole other era of moon exploration.
Yeah, correct.
Well, we do have a guest from chat in the meantime about the moon. Leslie guesses that if the moon is not spinning, I think you could see the conjunction from the dark side, which is an interesting guess. So we do have a dark side to the moon because it spins at exactly the same rate it orbits. So if you were on, this is a hard one because you have to remember the moon's phase, I believe, was waxing gibbous, is what we said before. So it's on its way to full. So if you were facing onto the dark side of the moon currently, you would have the same problem that Earth has, and that you would need to look towards the sun in order to see Jupiter and Saturn line up. But you could do it if you weren't too far over. So you're maybe right on the edge. That's my guess anyways.
Thinking in the right way, problem solving, it's making sense.
Yeah, so maybe if you were like right on the terminator edge of the moon now, because it is on its way to full, it is of course going around to the other side of Earth. But Earth isn't necessarily going to block your view if you're on the right edge of the moon. You'd still be able to catch that angle. And the key thing to remember with this one is, of course, the distance between Earth and Jupiter is much, much greater than the distance from Earth to the moon. So really, it doesn't matter much in terms of the angle of approach, as long as you're on a side that you can get that right, sort of view where you line up with, of course, I can't find the figure anymore. You line up with Earth and, oh, here we go, this one. Yes, so if you have that blue dot and this figure, that more than encompasses, Earth and the moon in this particular diagram. So your Earth and moon could both be in there. The moon is obviously headed around to the dark side of the Earth going full, but it's not all the way behind, and Earth wouldn't block your view because there's not currently a lunar eclipse. So you would be able to see it. So Leslie is correct, but it's not quite the right reason. So very good. Thank you for your guess.
And of course, if you're on lunar near side with the sun shining down on you, the sun and the Earth, because there is no atmosphere there, you should still be able to, as long as the sun is more than 20 degrees above your local horizon, you should be able to see the planets even with the sun in your local sky.
Just don't look right at the sun.
No. Bad news.
Yes,
I believe that's.
I can't say that one too often. Do not.
I think Noah had a quick shout out for the Canadarm3 company.
Yeah, so something really interesting, just going back to the moon missions, was that the Canadarm3, the company that was selected to build the Canadarm3, that I believe also built the Canadarm1 and 2, is actually based in Brampton. So the Canadarms were all built right near York U, which is really exciting. And they also recently followed us on Instagram, so feel free to keep an eye out for them, for their account and all that they are doing.
I will say that I am currently in Brampton. I'm born and raised Brampton. So knowing that the coolest space robotics company on the planet that makes the Canadarms is in like the backyard, that's super cool.
Quite true. There are 4 active Canadian astronauts at the moment. So I'm going to go out on a limb and say one of those 4 is going to actually be on that 2023 mission.
Oh, I wanted to say, yeah, I'm glad that you brought it back to that, Paul, because one, we have those 4, but what does this speak to the next astronaut class? Because if there's a pathway forward for Canada, we're going to the moon, we're going to the lunar gateway, there's probably going to be more missions. I would bet sometime in the next, say, 5 to 10 years, there's going to be a new call for a Canadian astronaut application process. So if you are thinking about it, start building your resume now.
Start flying lessons, absolutely. Yeah. Study hard.
Yeah, there's so many incredible people. I don't know if you remember the last application process. There was like the short list, which was 100 people long, was just the coolest people in Canada. So I wish we could hire at the same rate that the NASA astronaut corps get hired.
There were thousands of applicants too. The so-called short list of 100 probably came from about a 3,000, 4,000, or 5,000 applicant pool. There's lots of excitement when we are talking about, creating astronauts, shall we say.
Oh, yes. And, when you start getting more of a pathway open for people, it does become very, very exciting. I myself, I think I tried the NASA astronaut corps. I was only 15 and got my first rejection letter. So
it's an achievement in itself.
Yes, absolutely. You put in an application. That's fabulous.
That is far more daring than me. I've never put an application in. That's awesome. That's awesome.
Well, it is very competitive, and they do not accept 15-year-olds. So.
Well, not yet, at any rate. I mean,
Exactly. All right, so let's go ahead and let's go back to one more live view. Actually, I think this is a good time for it.
Yeah, good idea.
So we have India. Let's go ahead and try Italy. So this is live from Italy, from the Bellatrix Astronomical Observatory.
What a great name, the Bellatrix Astronomical Observatory. both as a fan of star names, but also a huge Harry Potter fan.
I don't think this was named after Harry Potter, but I could be wrong. So this is live from Italy. So you saw the live from India images coming through Jupiter and Saturn in the same field of view. This is live from Italy. So yet another part of the world able to view this conjunction. Like say, it's very, very exciting because it is so accessible to so much of humanity. It really is something we can all share. And this is one of the things I love about astronomy is when you get events like this, they're for everyone. We can all go see it. So if you're in the general Toronto area, have a look right now. It's still up. You can catch it. If your skies are clear, just look to the south, southwest. Just after the direction of the setting sun, you should see a very, very bright object up in the sky, just below that's where the sun set. Just above where the sun set.
Just below the sun, yeah.
But flip yourself around, so stand on your head. All right, stellar acrobatics aside, these are the live views coming in from Italy. And this is really, really nice because they've got a very wide field camera, so you're able to get the moons as well as Saturn and Jupiter in the same field. So they're just doing some adjustments. Obviously, this is they've still got a bit of sunlight to play with, trying to get the moons to appear a little bit brighter in that same field of view.
Yeah, that's looking great.
Yeah, this is a really nice set, and I think it really helps to have. At some points, having too big of a telescope actually makes it more of a challenge. So I know that in chat, a couple of folks said that they'd had a lot of trouble with their binoculars. Try looking at it just with your naked eye first, and then setting up your binoculars or your small telescope. Because if your magnification is on too high, what will happen is you'll zoom too far in and you won't be able to actually see it. So this is almost exactly the set of moons we saw before. So Ganymede, Callisto, Io, and maybe Europa as well. So I see 3 of the 4 Galilean moons in here.
The fourth get 2.
Well, the fourth one is actually being blocked by the planet. I'm not sure whether or not it is slipped behind, as in it's occulting by Jupiter, or whether or not it's in front and is transiting. But only 3 of the 4 are now actually visible. And I think the one that we're missing is Ganymede.
Yes, I think you're right. Excellent views. So this is a really nice live stream of the event, as I say, from Italy. So we're gone all the way across the ocean from Toronto. So we're doing a little bit of a world tour of live views here.
It's gone.
Oh, well, it's live, so it'll be back. As you can see, the thing with live views is they do adjust the
there you go.
They do adjust the cameras.
Somebody bump the telescope. Come on, we know.
Yeah, or change the focus, or something happened somewhere.
So it looks like Saturn is a little bit elongated in that, but I don't see any. I can't see Titan in that. Am I blind?
I'm not seeing it either.
Okay. All right.
No, it might just be a little. It is fairly faint. So
it's a magnitude fainter than the Galilean. So
yeah, that'll do it.
Yeah, exactly. And it's always really exciting to see when they can adjust the settings on the telescope and get some new views in.
Yeah, this is one of the fun. I think what you get lost in when you do astronomy, like backyard astronomy, or if you have access to a bigger facility, is you can get lost in this, in how fun it is to play with all the little dials and the contrast and the exposure time and all the things that you need to do to make that like perfect crisp view. It's a lot of fun to do something like that, even if you have just a simple telescope or a pair of binoculars. All right, what's happening there? Looks like they changed the exposure time.
Yeah, this must be a much lower exposure time, probably trying to bring out the detail in the planets. So if you turn up the exposure time, you can get a lot more detail on the moons. But if you turn down the exposure time, you can sometimes get more detail in the planets, although I'm still not really seeing much. So they obviously had a lot of clouds.
Yeah, it seems to be a problem plagued by everybody. There are clouds everywhere right now. It seems like the last couple of the last week has been sort of okay here in the Toronto area. I got out a couple of times to take a look at them, but today and pretty much everywhere, everybody I talked to today across the country is plagued with clouds. So luckily we are able to look at these views through these telescopes.
Yeah, exactly. And, you know, that's the great thing about collaborations, as we say. You know, even if you have a telescope, having friends with telescopes is sometimes even better because you can share the views and you can, of course, you know, help each other when the clouds roll in. Of
You know
course,
what?
Oh, sorry,
Sorry.
go ahead. I had a lunar gateway lead in.
Oh, okay. I just want to comment on having friends with telescopes because I literally have never owned a telescope in my life. I'm an astronomer. I wanted to observe things. That's what I wanted to do. I use the York Observatory one. I had my friend Harrison has one. I used one when I was back at McMaster University. That was the department's one. I always found a way to find the friends with the telescopes so that I could, you know, get out there and look at things. One of these days, I'm going to have to buy my own. That's for sure.
Oh yeah, well, you know, the trick is to stop moving long distances, I think. Having just moved to Canada from Australia, I can say you don't want to have too many things.
Did you bring a telescope along with you or multiple telescopes?
I did not.
No.
I do not own one for the same reason as I shifted countries too many times, and you end up getting rid of everything that's over a certain size.
And now you have a 1 meter.
And now I have a 1 meter with clouds. So we'll use our
Yeah.
friends. Oh, here come the Galilean moons again. Excellent. This might even be a clearer shot of the moons, actually.
Yeah, maybe the clouds and some cirrus is gone. That's beautiful.
Yeah, I can see all 4 Galilean moons.
Yes. I see. Okay, I think there's a little bit of a double thing going on because I thought I saw 5 points of light there. 1, 2, 3, 4.
There might be a little bit of a maybe a focus issue.
Yeah, it could be. Yeah, an internal thing. But that was a much clearer view, although it's now gone back to less clear. But whatever that was, whatever they had, that was a great view of it. And is that in the top left a simulated view?
Yes. So the top left is the simulated view of what you'd expect to see. The blurring out of this is obviously because of the atmosphere. So the atmosphere blurs the image and makes it kind of appear larger by smooshing the light around, basically. So,
one thing I want to point out to those listening and those watching is that one of the tools in our tool belts as astronomers and as like what these astronomers are doing in Italy right now is to use simulators to see how things are going to look, where they're going to be. And there's a lot of really awesome free ones. Specifically, there is one called Stellarium. So just Google Stellarium and it's free to download and it's really easy to learn how to use. And it's a lot of fun to you can prep for comets, you can prep for meteor showers, you can prep for eclipses, you can just look at the sky because it's awesome. You can prep for conjunctions. It's a lot of fun. So check out Stellarium.
Yes, and actually that's a good point. If you do open Stellarium right now, one of the users in chat just pointed out, thanks to Project, which I'm assuming is not your actual name, but yes, there is actually a bright star in the field of view, which is being caught by this live stream.
What's the name of the star, Project? Tell us the
name.
name.
Well, that will leave it as a mystery to chat. See if the chat can find it out for us, what the star name is. Okay. Now, we've talked a lot about this event and how cool it is that Jupiter and Saturn are in the sky. So I think the next thing to do is actually have our crew tell you a little bit about Jupiter and Saturn, just to get us well-rounded into some fun facts. So I believe, Noah, you're up first.
Yeah, so thank you, Professor Hyde. So yeah, exactly as you just mentioned, we want to share a little bit about what you will see when you view the Great Conjunction. We want to tell you a little bit about Jupiter and Saturn, the planets that are so visibly close together right now. Okay, so let's start with the farther of the two planets from Earth, Saturn. Saturn is the sixth planet from the Sun at a distance of 9.5 astronomical units. Due to this great distance, 1 year on Saturn, 1 revolution around the Sun is an enormous 29.45 Earth years. This immense distance creates an extremely cold surface temperature of approximately negative 138 degrees Celsius. Contrastingly, a day on Saturn is much shorter than our own, taking approximately only 10.7 hours to rotate around its axis. In this axis rotation, Saturn is actually tilted at an angle of 26.73 degrees, interestingly providing different seasons on the planet, just like ours on Earth, which are produced with an axis tilt of around 23.5 degrees, as Professor Hyde mentioned earlier. Saturn is a gas giant, composed mostly of hydrogen and helium, and it is the second largest planet in our solar system, the largest after Jupiter. The planet itself, though it has an average density less than that of water, is actually more than 9 Earths across. So something that reaches even farther than the planet itself is Saturn's famous ring system. It is comprised of ice, rocks, and dust, or debris that is thought to be from comets, moons, and other astronomical objects. These rings reach 282,000 kilometers away from the planet and consist of 7 different rings, each of which orbit at different speeds. You may have heard of the Cassini division too, which is a 4,700 kilometer wide gap with no debris between 2 of the rings. Did you know that this debris ranges in size, such that some are as small as a grain of sand, while others are as large as an entire mountain? These rings, though incredible to view, are not actually the only rings in the solar system. The other giant planets, Jupiter, Uranus, and Neptune, have them as well. Saturn's are merely the only ones visible to our eyes from Earth. Saturn actually has extremely interesting weather, too. First of all, the stripes that can be seen when viewed are actually clouds. In the upper atmosphere around the equator, these winds reach a whopping 500 meters per second, or around 1,800 kilometers per hour, in comparison to Earth's fastest wind speed at 110 meters per second, around 400 kilometers per hour. Not only that, but there is a hexagonal jet stream at Saturn's North Pole, which consists of 322 km per hour winds spanning 30,000 kilometers. At the center of this jet stream, too, lies a 2,000 kilometer wide storm that swirls at 150 meters per second. Something else interesting is the magnetic field of Saturn, which is 578 times the strength of Earth's magnetic field. Now, let's move outside the planet, its rings, and its atmosphere. Saturn has 82 moons orbiting it, the most moons out of any planet in the solar system. Some of the main moons include Titan, Hyperion, Enceladus, Mimas, Tethys, Dione, Rhea, and Iapetus. Titan, Saturn's largest moon, is actually bigger than the planet Mercury, whereas Enceladus is extremely icy and is therefore the most reflective object in the entire solar system. As for a little bit of history, Saturn was the farthest planet to be detected with the naked eye from here on Earth. Since then, it's been visited by 4 robotic spacecraft, beginning in 1979 with Pioneer 11. However, the most thorough mission was Cassini, which orbited Saturn between 2004 and 2017, completing a total of 294 revolutions. Where did the name Saturn come from? It is named for the Roman god of agriculture, the Roman aspect of the Greek titan Kronos, who is, in fact, the father of Zeus, or Jupiter, the planet next door. Next, Gagan will tell you all about the other half of the Great Conjunction System, Jupiter.
Thanks, Noah. So Jupiter, next up, is the largest planet in our solar system and the 5th planet from the Sun. It orbits at a distance of 5.2 astronomical units from the Sun, which is over 5 times the distance between Earth and the Sun, as Professor Hyde mentioned earlier. It's also a gas giant and is more massive than all the other planets in the solar system combined, so that's really huge. It's mostly comprised of hydrogen and helium, just like Saturn. And there is speculation of a rocky core at the center, but currently we consider it not to have a solid surface. So Jupiter's atmosphere is really complex, and it's over 5,000 kilometers deep with bands of clouds and atmospheric currents. It's also really stormy, with lightning even being seen in some of the deeper layers, which is indicative of clouds of water. Most notably are the enormous hurricane-like storms that can be seen even from Earth. The Great Red Spot is the biggest storm on Jupiter and is large enough to encompass 2 Earth diameters and can be seen from land telescopes on Earth. The Great Red Spot can be seen in the image on the right and closer up in the image on the left. Jupiter's south pole also stays swirling with storms, as you can see in the middle image taken by the Juno spacecraft. Jupiter's stormy atmosphere is fitting to its name, which comes from the Roman god of the sky. Just like Saturn, Jupiter has a very extensive moon system, with 79 confirmed moons. However, more small moons are being discovered relatively often. The number of confirmed moons sat in the 60s just a few years ago. Nevertheless, Jupiter is also home to some of the most interesting moons in our solar system. The 4 Galilean moons in particular, in order of their orbital radius, are Io, Europa, Ganymede, and Callisto. They are Jupiter's largest moons and all are visible from Earth with a small telescope. Ganymede, which is the largest of the 4, is even larger than Mercury. We've observed a lot of really interesting phenomena on the Galilean moons. Io, for instance, is the most volcanically active moon in our solar system and has over 400 active volcanoes. It also has some mountains even higher than Mount Everest. Europa, on the other hand, is thought to have a massive subsurface water lake surrounding its mantle, and one of the most promising candidates for life in our solar system. Ganymede and Callisto are also interesting subjects of research because they actually have thin atmospheres containing oxygen, and Callisto is the most cratered moon in our solar system. Since Jupiter is the 4th brightest object in the night sky, only after the Sun, the Moon, and Venus, it's easily visible and identified even with the naked eye. Because of this, Jupiter has been the subject of observation since at least the 7th or 8th century BC by many civilizations and cultures. Galileo is considered the astronomer who discovered the 4 Galilean moons with a telescope, but other records actually show a Chinese astronomer named Lord Gan may actually have identified one of Jupiter's moons almost 2,000 years earlier without any visual aids. Records indicate that he discovered either Callisto or Ganymede, which are Jupiter's largest and most outermost moons, with the naked eye, which is pretty insane considering skies back then were really crowded. More detailed observations of Jupiter were not possible until after the development of telescopes, and more recently, our research comes from several space probes or orbiters whose missions included Jupiter, for example, the Voyager and Juno missions. Missions like these, as well as the improvement of telescopes, have been integral to our understanding of Jupiter and Saturn. This conjunction brings both planets close enough to be viewed at once through a single telescope, which is an awesome observing opportunity. And although it's cloudy in Toronto right now, and we wish we could show you how it looks through our 1-meter telescope, please try and catch a glimpse of this conjunction if you do have clear skies.
An excellent summary, and of course, an excellent idea. Of course, well, if you do have clear skies, make sure to send those images up onto social media so we can all look along with you. And we will be sharing more live images from various telescopes around the world where there might be a little bit less clouds. So we have seen, let's see, where in the world have we gone so far?
No, we did Italy.
We were in Italy and India. So I think actually South Africa is the next live views that we have on the sort of the live view menu here. So I'll just go ahead and turn those on. And this is from the telescope time machine, which was running a live stream from South Africa, which, as you may recall from our earlier discussion, they had their closest approach earlier than Toronto did. So this is showing the great conjunction, and all credit to Corey Schmitz, who was running this live, and through a fairly wide field of view as well. So we should be able to get, I believe he started off a bit cloudy, so I'm just going to skip through some of the clouds. But he combined live views through a Skycam and I think a 14-centimeter telescope. So this is the live views coming in from South Africa. Looks like they've got an extra mirror in there to flip it around. And Jupiter is at the top. And we'll just see if we can get.
Yeah, that's a fun point that you just mentioned, where the extra mirror in there to flip it around. I think if you don't play with telescopes a lot, there's sometimes you have images one way, sometimes you have them the other way. It depends on the way you've set up your optics and for what reason you're setting your optics up that way. And so this is cool to be able to see it like, no, it's not different. It's not like everything has flipped around. It's just the mirrors are different inside.
Exactly. And so, yes, it's worth noting that if you look through a small telescope, you will often get your view upside down and sideways, because they don't bother to flip it right side up for telescopes. But if you're looking through binoculars, they do actually flip the view around, because through binoculars, you want to see the distant objects right side up as they would be in the real world.
Yeah, binoculars are used for more than just astronomical observing. They're used for like looking at birds and stuff. You don't want to see a bird upside down and sideways. That'd be weird.
Yeah, and there's no real up in space, so usually astronomers don't care how they're oriented. We don't bother flipping the image around again, because it's like, well, what direction is up really? How is there any such thing? And it's no.
Astronomers are the best. They're like, they go through all this. They put tons and tons of work and care into like grinding the mirrors or forming the lenses or whatever. And they're like, someone says that's upside down. They're like, yeah, but it doesn't matter. I can still see it good.
One more thing while we're talking about looking at objects, we are all used to seeing the moon exhibit its phases here in the Northern Hemisphere. Think about how those phases will look to you if you go and observe them from the Southern Hemisphere.
That is a really fun mind trip.
It is.
For those that don't visit the South or don't go to the South often, or vice versa, who live in the South and never come to the North. That's
right. It really is different. I've said this many times, but all the way back in 1993, when I visited Australia with my children, we walked out of Sydney Airport at 6:30 in the morning, and completely spontaneously, my oldest son, Sean, looked at the moon and said, "Dad, it's upside down." I was so proud. I was just so proud.
Did you then quickly say to him, no, this is right side up?
Oh, I should have. I did. I was just so proud. Actually, more to the point, I was looking to go to bed because we'd be traveling for 24 hours. But anyway, that's a whole other issue. But the perspective of looking at the moon phasing from the Northern Hemisphere versus the Southern Hemisphere, it will flip. No mirrors. It's just the perspective of looking at a relatively nearby object, the moon, with the the various phases from two distinctly different locations on our planet.
Yeah, you have just flipped yourself is all that's happening.
Yes, that's right, exactly.
Yeah, we tend to, this is like Earth is a ball, right? Earth is a sphere, and people who are on the Northern Hemisphere have their heads pointing one direction in space, and people in the Southern Hemisphere have their heads pointing the other direction in space. So you're literally upside down compared to each other.
That's right. Exactly.
Indeed. This is good. Gets into the same reason why we see different constellations at different times of year as the Earth goes around the sun as well. So once you start picturing the fact that you're literally on a ball looking up, it makes a little more sense, but it kind of hurts to think about. So don't picture it too accurately, or you might get dizzy.
Absolutely.
Wonderful image that is being shown from South Africa. I'm really, really envious of all these observatories that have clear skies. Wonderful images.
Yeah, that was a great
South
one.
Africa had some very clear skies for a lot of their live broadcasts, and as you can see, they were able to get live cam views from the sky, as well as views of the event itself with the Galilean moons, and of course the mystery star, which I believe we're still waiting for our chat to identify.
Oh yeah, I forgot to go look. Did anybody answer that?
Not yet. So we'll see. You look it up, and we'll see if anybody gets the right answer. All right. So as you can see, we still have the conjunction live views coming in, this time from South Africa. And again, in case you missed it before, of course, this one, all credit to Corey Schmitz. And lovely, lovely images coming through. Not quite the absolute closest approach, but very, 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 very good views coming through. And you can see as the focus adjusts on this as well, they sort of turn up the contrast or allow for more light to come in so that you can see the moons, and it makes the planets very, very bright. And then you turn down the contrast or turn down the amount of light you're letting in, such that you can try to bring out more detail of the actual planet itself. And you can see again that elongation of Saturn. And now you all know, of course, thanks to our wonderful students and crew, Gagan and Noah, who told us all about Jupiter and Saturn and what they really were. And of course, they are, actually quite similar sizes in, their radii as well. So it's worth noting that because, we can see this, and Saturn is twice as far away as Jupiter. And if you kind of imagine that actually they're really the same size, it doesn't give you quite an accurate feel of the distance, but you kind of get a little bit of, this is how the distance must be operating. All right, so wonderful views again from Africa, and we'll just let that go for a little bit here because I want to make sure we catch as many of the views as we can.
Yeah, that's why we're here, right?
Exactly. So we have a lot of wonderful views from all over the world, just not unfortunately from Toronto where we are, because I just checked a second ago, and it is still too cloudy, unfortunately. So we'll keep on trying to show you the views, and if the sky does miraculously clear at some point in the next 23 minutes, we will still open. But I am not going to try to get anyone's hope up too high for that one.
But luckily we have these awesome views, and this, like, just being able to see this image right here from South Africa, you can see the bright Jupiter and the little rings of Saturn there. Like, it's just an incredible view. Saturn is 2 times further away out into the universe, orbiting the sun, than Jupiter is, but we have them in that little field of view of this telescope. It's super cool.
Exactly, and it is, if you are looking with binoculars or a small telescope and you do have clear skies, you can be assured that we are all super, super jealous.
A little, for those that have binoculars, and if you're trying to do it with your hands, and you're pointing your binoculars like this, it can be a little bit difficult if you feel like you're having too much trouble anchoring your hand, like your elbows or yourself up against something like a fence maybe. But the best way to do it is to get yourself a tripod if you have something like that.
Absolutely, or even a homemade tripod will give you enough stability to balance yourself and get a more accurate view. So there's one more location I'd like to stop to that does have a really nice live stream, and this is one we found earlier from Abu Dhabi, and this is a really nice clear sky over in the UAE.
It never rains there, so that's not much of a surprise. I mean.
I don't know. I actually don't know how much rain they get. That's a good trivia question. But I have heard it is indeed not very much. So this is live skies from Abu Dhabi, and this is all credit to the Al Khatim Observatory. So continuing a long tradition of really amazing observatories in the region. And yes, wonderful views from their live stream. They did have some rather poor seeing at the beginning, but they were able to get it to clear up pretty spectacularly later on.
That looks looking good.
Yeah,
that looks great.
The way they've adjusted the coloring and the exposure on this telescope is really quite excellent. It gives you, I think, a really genuine feel of how this would look through the eyepiece of a telescope or a pretty big pair of binoculars.
Hat goes off to the UAE as well. They've got a mission to Mars at the moment, which will be landing in February.
Yes, Hope was it? Or no, wait, that was the, yep,
I think it was Hope.
yep. And
So,
that does have a lander attached.
It does. Okay. I'm
I
not
honestly can't remember.
Okay.
sure either. I don't.
Another trivia question.
I believe that this one's just orbiting.
Yeah, I think Gagan is correct. I think we've just got an orbiter. I mean, heavens, that's an amazing effort if they're successful in getting it into orbit. But I don't think this mission has a lander. The U.S. Perseverance and the Chinese Space Agency, they do have landers, but I think the UAE's Hope mission is just an orbiter.
Oh, we have a guest for the star, actually, from earlier in chat. HD191250. Have you got that, Jesse?
I do, and I have the same. So I have Stellarium open as well, and it's not in the same place, but obviously the live view that we were viewing from Italy, I think that was the one.
Yep.
Is at a different time than my live view of Stellarium is right now. So I think 191250 is near Jupiter right now. So Jupiter could have slid past it, and that could definitely be it.
It was an occultation. Yes. Sorry, I was away when that conversation broke forth. But yes, there was an occultation event by Jupiter visible from the southern hemisphere during this close conjunction.
Wonderful. So we actually, it is very fortuitous that you did manage to discuss occultations as well as conjunctions.
What can I say? I mean, I'm paid to try and bring in the right stuff.
So congratulations to Project for posting that. It looks like a couple times.
Trying to get our attention.
Yes, like I know it. Thank you very much. You are correct and very, very nice.
Oh, look at that view from Abu Dhabi. That's amazing.
Very steady air there.
Yes, and this is a little follow-up for anybody in chat joining now. If you are looking up in Canada and you have clear skies, you can still look towards the south-southwest and see this for yourself as a bright star. It is going to be low on the horizon now. It is, as you say, following the sun down. But if you have clear skies, you can still go and see it as well. So if and don't let our own clouds stop you all from running outside and having a look.
Remember as well, if it's not clear tonight, race out tomorrow night, same time frame, sort of from 5 o'clock through to 6 or thereabouts. It will be almost as close tomorrow night, not as close, but still spectacularly close.
Although each day it's getting closer and closer to the horizon, isn't it?
Yes, correct. Yeah. We can't avoid that, I'm afraid. That's celestial mechanics. Nothing we can do.
Yeah, the view of Saturn there, what's wonderful about it is you can see the gap between the rings and the planet, which is the other views. I don't think I was able to resolve the actual gap between the two. And that was something that Galileo wrote about way back in that would have been in 1612 or 1610. Yeah, and he said before he had them as the ears, and then he said, no, wait, I think they have these little black triangles. And he didn't quite know what he was looking at, but he was looking at the gaps between the rings and the planet.
How would you have possibly have guessed what you were looking at when you think about it? I mean,
it's a completely unknown foreign thing. Like, why would you think that rings exist out there in the universe? I mean, it wasn't that long after, though. Like, Huygens properly described what they were maybe like 30 years later or something like that.
Probably closer to 40, but same time frame. Yeah. No, we accelerated forward in our understanding there very quickly with the development of telescopes. And of course, by the end of the 17th century, reflecting telescopes, Newtonian telescopes had joined the Galilean refracting telescopes. It was an exciting century as far as astronomical observation was concerned. You know
what I love about that as well nowadays is that we're still in that sort of fervent race to build the bigger telescopes. Like every 5 years, every maybe 5-10 years, we're like, no, let's build it bigger. Like let's add 5 meters. No, that we want 10 meters. No, we want 30 meters. When will it stop, Paul?
Well, that's a really good question. All through my formative years of education, the 5-meter Palomar Observatory was it. That was as big as we could go. We didn't think we could build them any bigger. And then astronomers in the mid-1970s started thinking outside the box, I guess would be the best term. And that's when the next generation of behemoths as far as reflecting telescopes were concerned. That was the genesis of the ideas. And it was, of course, Roger Angel and company in the mid-80s where we were able to start casting 6-meter diameter mirrors, and now 8, 10, they're common sizes. And as you say, Jesse, we're in the process of building 2, hopefully 3 30-meter class telescopes to be christened within the next 5 years.
Indeed, just wait until they get those 3D printing machines put up on the moon, and then you'll really get a telescope.
Oh my gosh.
All right, so we now have even better live views just coming in from Abu Dhabi. So this is not our telescope. This is live views. All credit to the Al-Khatim Observatory in Abu Dhabi for bringing these in. They have increased their exposure so that the images are brighter, bringing out the Galilean moons. This has made both of the planets quite bright, so the rings of Saturn start to blur a little bit within the planet itself, but it is an absolutely lovely view.
The 3 Galilean satellites there are very clear. Still can't see Titan, which is unfortunate. That's not a criticism of them. It's just a statement. You can't quite see Titan yet.
No, I can't pick it out. Though you can still see the gap between the rings and the planet,
Yes.
which is really great.
They've got really steady air. Do you know what telescope they are using, Elaina?
At the observatory, I believe it was a medium-sized telescope, but I didn't get the specs on that. That would be a great follow-up. It looks like, as you say, they had an absolutely wonderful still set of skies. Jealousy-inducing weather here.
Oh yeah, no question in the world about that. More than a tip of the hat, it's to them, that's for sure. Planets are so nice to look at. I mean, the moon also, let's give a shout out to the moon here. It gets a lot of grief from astronomers because it's this big, bright, naturally light polluting object in the sky. And when we're trying to see something faint, you don't want the moon around the place. However, to captivate the public's attention, the moon is beautiful, especially when it's near first quarter phase. The Terminator, the shadowing in the craters, the casting of the mountains. It's just a wonderful object to look at to really excite people.
I'm loving this. The chat room in the YouTube is just loving this view. They're all just saying how great it is.
They are all right. This is why we had actually saved kind of the best for last. This is some really spectacular clear skies. And this is really this is why people build their telescopes up on top of large mountains in the middle of nowhere, and maybe not all on campuses like we are. But weather can really help in terms of image quality, and having less atmosphere or less moving air or stiller air between you and outer space means that the light passes more directly through. You get much, much sharper, more beautiful images.
Wow, that's amazing. I'm loving this. I could look at this all day.
Yeah, this is a dramatic representation of clear skies, that's for sure. Relatively little water vapor, so the seeing conditions are obviously really, really good.
And this is one of those greatest, it's a great conjunction. It's not going to happen again for 20 years, and it certainly won't be this close again for at least until 2080. What did you say, Paul, 400 years from now?
397, give or take a month.
Yeah, so that Jupiter and Saturn so close together on the sky. It's so great to see.
And in 397 years, it will not be happening on the solstice. So
that's true.
That was purely fortuitous today. There was nothing about the solstice which was driving the conjunction of these two planets.
it is pure good luck. So hopefully this is more luck to everybody.
I know I had so much to tweet about today. It was awesome.
Now, of course, I'm going to say I'm sad that it's the solstice because the days are getting longer. From the astronomical point of view, I like long, dark nights. I get lots of observing done, but from now on, it's getting shorter. Oh, sigh.
But you are getting into the best observing season, right?
Yeah, you're right. There's no question in the world about that. January, February here in Southern Ontario are pretty good. And then late spring, May, June, July, they're pretty good too. The worst observing time here in Southern Ontario is October and November. And this year, it wasn't as bad. As Elaina will well know, we managed to get lots of clear nights for our classes in early November, and they took full advantage of it. So it's been a bit of a strange year for weather.
Awesome.
Yeah, and I just will go ahead and say that in chat we have a mention, someone has looked up the Abu Dhabi telescope is 16 inches in diameter.
Yeah.
So it is a reasonably sized telescope. Obviously we can claim our 1 meter, telescope diameter of fame here, but because we got clouded out and they didn't, they are definitely winning this conjunction imaging contest. Just a little comment of a couple people wanting to know a little bit more about the moons they are seeing. Now, we were saying that this is probably, now this was earlier today, so Ganymede is probably behind Jupiter. So Io should be the one that is closest to Jupiter at the moment, which it kind of has been fading in and out. That would be the one mentioned earlier as the volcanic moon of Jupiter. And
I'm betting
that's
that
Europa.
the closer one?
No, sorry, the highest one I think is Europa.
and then the bottom one is Callisto.
Callisto.
Yep.
Oh yeah. Okay.
Yep.
Yeah.
I'm just going back and forth.
As seen earlier. So, and just as a little reminder, Io was the moon that had, all of the volcanic activity and looks like a kind of a really active cheese pizza. And the other moons are all very icy and watery. And, of course, containing liquid water underneath the surface, as in the case of Europa, and possibly Ganymede.
Yeah, Ganymede, the one that we can't see at the moment, is of course the largest satellite in the solar system. Beats out Titan by only a few dozen kilometers, if memory serves, but technically Ganymede is the largest satellite in our solar system.
All right, well, I hesitate to go away from live views, but we do have a little bit of history, so we will come back to this if there is time for more wonderful live views. Now, go ahead and hop over to the history section here.
So that's a good idea.
Really fun history.
Sorry, Elaina. That's a good idea. I'll mention a couple of them, and then we can go back to the live views to finish it off.
Excellent. And do you want to run those, or shall I?
Why don't I run them? If you don't mind, I'll just take over.
Yeah, go for it.
And that way I can pick the ones that I want to go through, and let's see, pick that.
All right, well, we're just arranging our screens for you here shortly, and Jesse has a little bit of fun history here.
Okay, so one of the things I wanted to point out is that conjunctions happen. There's lots of different conjunctions that happen. We've talked about today about Saturn and Jupiter, but just like last year, there was a great one. Here's one between Mars and Mercury that was really, really close. Just 12 arc minutes, which is about 2 times as far as what is being shown between Jupiter and Saturn today. And then Venus and Jupiter is always a really brilliant type of conjunction, because Jupiter and Venus are some of the brightest things on the sky, next to the moon and next to the sun. So Jupiter and Venus are super, super bright. And here was one from August 27th, 2016. And you can see right here, this is the simulated view of the two of them, but this is a view from an astronomer named Luke O'Brien, who took an image of on this day of the conjunction between Venus and Jupiter. So you can see how brilliant Venus is in this image, and you can see the moons there and Jupiter, how close they got together. And this was about 5 arc minutes apart. So this is closer than Jupiter and Saturn are today. Some things, I'll clear up some things about how long ago the last great conjunction was that was this close. So today we have a great conjunction between Jupiter and Saturn, and they're about 6-ish arc minutes apart from each other. So just keep that number in mind. The last time there was a conjunction that was closer than that was in 1623. And this is Galileo times. Galileo had just started using telescopes, and there was this incredible conjunction that was happening that was super, super close. However, as Elaina has already pointed out, the conjunction was happening super close to the sun. And you can see right here on this side of the image here, you have the sun there, and Jupiter is not too far away from it, just about 13 degrees away from the sun. And so it was actually not very visible. There were some places around the world that it may have been visible from, but it wasn't really a grand conjunction for everybody. So if you keep going back, there was another great conjunction that happened in 1563. And this one was almost as close as today's. And this one was really, really cool because they used this conjunction to compare two different models of the universe. They compared Ptolemy's model, which was a geocentric model of the universe, and they compared Copernicus's model, which was a heliocentric model of the universe. And those two models can predict where the planets are going to be on the sky. And the Ptolemaic model predicted that the conjunction would happen on about 150 arc minutes apart, so in a completely different distance, whereas the Copernican model had the correct date, but that Jupiter and Saturn were just a little bit too close to each other. So what I'm trying to say is that ancient scientists were able to use great conjunctions to determine if models of the universes needed tweaking or which one was better. And they concluded in this case that Copernicus's was a little bit better at modeling conjunctions. Moving backwards even further from that, we go to 1226. And this was the last time that a great conjunction was observable and close together like the one that we see today. So this is 2.1 arc minutes, super, super close. And it was observable to a lot of people on the planet. It was around the time of Genghis Khan and Nasir al-Din Tusi, who was an incredible astronomer. I wanted to point out just one last thing, because there's a lot of history to go through and I don't have enough time. But one question you might have asked yourself, at least I definitely asked myself this question, is can Jupiter ever pass in front of Saturn? They can get close together on the sky. We're just looking at live views of Jupiter and Saturn being super close together, but can they ever occult each other or transit each other, as Paul was telling us about before? And the answer to that is maybe, and here's why it's maybe. So we have a really strong understanding of the orbits of the solar system, but all of our measurements have a little bit of error in them. We can only measure things so precisely. Now that works really, really well for 500 years prediction, for 1,000 years prediction. But when you get further and further and further on in your predictions, those little uncertainties in the knowledge of the orbits of a planet eventually build up to a point where we can't be super confident in, especially to the precision needed for this. So in order for Jupiter to pass over some portion of Saturn, the separation between the two of them has to be as small as 0.4 arc minutes, which is really, really small. It's 10 times closer than how close they are today. So for them to be that close on the sky seems to be pretty rare. I have here a possible prediction of it happening in, what is the date there? 7,541 is the next time this might happen. So whoever is observing the sky at the year 7,541 is going to see possibly this and this. However, this isn't without some uncertainty, and it may not be perfectly overlapping in the way that these images show here. Now we're up against the end there, so I'll leave it at that, and I can pass it back to Elaina so that we can go back to some live views.
Excellent. Yes. So we'll need to work on our cryogenic freezing of humans if we want to do this next one.
7,500 years. Wow. Okay.
And it may not even be true. I mean, the uncertainties I think are a little bit unwieldy at that point, but this is the best guess.
Yep, I think I have read that too, but they weren't as succinct about the error bars as you just were. So I'm not going to hold my breath, I guess, on that one.
All right, so we're just going back to the live views from Abu Dhabi, just because they were so spectacular. So this is additional live views, sort of kind of picking up where we left off last time, of the Jupiter and Saturn Great Conjunction of 2020 on the winter solstice summer solstice here, and lovely, lovely views coming through. Thank you for the fun history, Jesse. As so Jupiter passing in front of Saturn, improbable, but much more likely than them going in front of the moon.
Yes,
I'll
that's
put
true.
money on that one. Absolutely.
Yeah, the history of conjunctions is really rich. I implore people to go and do some Googling. Lots of great stuff was observed over the years, and there's a possible quintuple conjunction coming up in the future, where all 5 of the visible planets are kind of close together on the sky. Not this close, but kind of close together.
Oh my gosh, is the world ending again like the Jupiter effect in 1980? Oh, no, sorry. We won't go there, will we?
No, not today.
No, not today. But that was a real thing, the Jupiter effect, 1980. If you're Googling about conjunctions and the like, go check that one out. Oh, sigh. But anyway.
I don't think I've heard that story.
Oh, yeah. Well, it was a so-called alignment of the planets. Now, of course, that was a very loose terminology because the actual separation from one planet, from the closest planet Mercury out to the farthest planet at that point in time, Neptune, it was nearly a 100-degree arc, but nonetheless it was referred to as an alignment of the planets, and it was going to generate earthquakes on our planet and literally the end of the world. The authors of the book that came out about it, they made lots and lots of money and did declare about 5 years after 1980 that they were wrong.
Well, at least they declared themselves wrong.
Yeah, but they laughed all the way to the bank in the process.
Yeah.
It was sad. Anyway, the Jupiter effect.
You know, it's funny. I know we don't have a lot of time left, but I'll just keep talking. So I remember first year astronomy it was a year-long course. I was at McMaster. I was 18 years old, and the professor, Ralph Pudritz, he said he put this as an assignment, and we had learned about celestial mechanics and we learned about orbits, and he said, okay, if all the planets aligned, what would the gravitational effect be on Earth? And we had to go home and figure it out. It was an awesome assignment, and from then on I fell in love with astronomy.
And the answer was, by the way, do you remember?
I don't remember the numerical answer. I did figure it out, but it was very small.
Infinitesimal.
Yes.
Correct.
Yeah, well, this is one of the things that is very hard to picture in astronomy, is even if you took all the planets together, they're just so much smaller than the sun, and they're so much farther away than any of us can easily picture. The distances out there are absolutely vast, and the fact that Saturn is already twice as far away as Jupiter, and you get these incredible distances out in the outer solar system. So it's really, really mind-boggling and worth playing with if you like to try to kind of imagine the incredible, fantastical scenario of just how vast these distances are and how much it really is just, everything is just grains of sand compared to the sun, or specks of
dust. Yeah.
Specks of dust compared to the sun, and I suppose Jupiter could be a very, very small peppercorn. In this particular analogy.
Yes.
But it is hard to picture as mere humans, and that's why these events are so fun. And this live view from Abu Dhabi is, I think, probably the best one that we're going to get a chance to see for this particular conjunction. So big thanks to the Al-Khatim Observatory in particular.
Yeah, it's beautiful. Look at that.
Yeah, superb, just superb. Nice way to end the broadcast. Yeah,
and we probably should start wrapping up now. So we are going to go ahead and reach the end of this broadcast here shortly. We would love to stay with you all night, but unfortunately, it is about time to wrap up. Jupiter and Saturn are setting in the Toronto general area, so if you can look out and have clear skies, you will get a chance to view them. And if not, well, there are lots of wonderful live streams that you will be able to play, including this one, which is recorded. So we'll go ahead and start wrapping up here a little bit. And we'll go ahead and just say, thank you everybody. Thank you all for coming for our event. And we really appreciate everybody arriving despite the cloudy weather. And we're glad we were able to pull in some live views from other fabulous places on Earth, even if we couldn't bring you our own. And you have been listening to the Elaina Carswell Observatory's special event TeleTube broadcast for the Great Conjunction of Jupiter and Saturn of 2020. So this is in fact a spin-off of our regular show, and that is every Wednesday at 7:30 p.m. EST. So just as a little wrap up here, we'll go ahead and say that if you like the show, feel free to tune in on Wednesday and see our regular broadcast. Now for the holiday, we will be running reruns of some of our previous episodes, and we will be going ahead and doing some of our top favorites from this last year while the normal crew is on break. This show is a regular broadcast from our astronomy and astrophysics program, and this show, as all of our shows, are written and presented by students, faculty, alumni, and friends of York University. So have a wonderful holiday, and we will return with new content in the new year. Make sure to tune in if you'd like to catch some of the reruns. The hosts this evening have been Gagan, Noah, Professor Delaney, Professor Rogerson, and myself, Professor Hyde. Make sure to leave any comments or questions in the comment section of the video. And of course, thank you for all of your wonderful questions tonight. All of our programs are free, but if you would like to make it a donation, you can see our website at observatory.info.yorku.ca. And you can always connect with us on Twitter and Instagram, the handles at York Observatory, and Facebook at Elaina Carswell OBS. You can check out our website for show notes, content updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, everyone. Clear skies and have a great night.